Bismillahirrahmanirrahim. In an experiment with equiprobable outcomes, the partition is S is equal to 1, 2, 3, 4, and probability of each outcome, probability of S, is equal to 1 over 4 for all small s element of this partition S. Are the events A1, which is equal to 1, 3, 4, A2, which is equal to 2, 3, 4, and A3 null set, are mutually independent? So we need to determine the independence of three events, right? So we are given that S is equal to 1, 2, 3, and 4, right? And probability of each outcome is 1 over 4. This is an equiprobable probability space, and the outcomes are equally likely, right? And the event A1 is equal to 1, 3, 4. A2 is equal to 2, 3, 4, and A3 is an empty set, right? So three events, A1, A2, and A3, are independent if and only if these conditions hold. The number one, probability of A1 intersection A2 intersection A3 is equal to the product of their individual probabilities. Probability of A1 multiplied by probability of A2 multiplied by probability of A3, right? And part B, that A1 and A2 are independent. The two events A1 and A2 are independent. Condition C, that A2 and A3 are independent, and the fourth condition, that A1 and A3 are independent. So let's first determine this first condition. So A1 intersection A2 intersection A3, let's find out the intersection. So A1 is this, A2 is this, and A3 is a null set. So intersection with the null set results in a null set, right? Empty set. So now the probability of this intersection is equal to the probability of this null set, which is equal to 0. Let's call this equation 1, right? Now the probability of A1 is each outcome is equally likely, so probability of each outcome is 1 over 4. So that is 1 over 4 plus 1 over 4 plus 1 over 4, that is 3 over 4. And probability of A2 is again 1 over 4 plus 1 over 4 plus 1 over 4, that is 3 over 4. And probability of A3, it is a null set, is equal to 0. So the product of their individual probabilities, probability of A2, probability of A3, is equal to 3 over 4 multiplied by 3 over 4 multiplied by 0, and this is equal to 0. Probability of A1 multiplied by probability of A2 multiplied by probability of A3 is equal to 0. So comparing 1 and 2, we see that this first equality holds. Probability of A1 intersection A2 intersection A3 is equal to the product of their individual probabilities. So this first condition holds, but on this condition alone, we cannot decide that the three events are independent, right? So we must determine the individual independence of the each pair of events A1, A2, A2, A3, and A1, A3 also, right? So let's find out whether A1 and A2 are independent or not. So A1 and A2, two events A1 and A2 are independent if probability of A1 intersection A2, that's the probability of A1 and A2 occurring together, is equal to the probability of A1 multiplied by probability of A2. So we have already determined probability of A1 to be 3 over 4, probability of A2 to be 3 over 4 also. So let's find out A1 intersection A2. So A1 intersection A2. So from here we see that the intersection is these two elements, this set 3 comma 4. So probability of A1 intersection A2, so the probability of each outcome is 1 over 4, so that is 1 over 4 plus 1 over 4, that is 2 over 4, that is 1 over 2, right? So let's call this equation number 3. Now probability of A1 multiplied by probability of A2. So probability of A1 was found out to be 3 over 4, and probability of A2 is also 3 over 4, so that is 9 over 16. So comparing 3 and 4, we find that probability of A1 intersection A2 is not equal to probability of A1 multiplied by probability of A2. So this condition does not hold for the set A1 and A2. So therefore the three sets A1, A2 and A3 are not independent. We can conclude it right here. Even though the three sets satisfy this first condition, that the probability of their intersection is equal to the product of their individual probabilities, but this one condition does not hold for them. So we can conclude that the sets A1, A2 and A3 are not independent. The events A1, A2 and A3 are not independent. We can conclude right here. So A1, A2 and A3 are not independent. Even though we have concluded, we can go on to find out the other conditions also. For example, intersection of A2 and A3, A2 and A3. The A3 is a null set, so intersection is also a null set. So probability of A2 intersection A3 is a null set, and the probability is 0. The intersection of A2 and A3 is a null set, so its probability is 0. So the probability of A3 is 0, so it means that probability of A2 multiplied by probability of A3. So probability of A2 was found out to be 3 over 4 multiplied by the probability of A3 is 0, right? So this is equal to 0. So this condition holds. Probability of A2 intersection A3 is equal to probability of A2 multiplied by probability of A3, right? And the third condition also holds similarly, because this is A1 and A3, right? So A3 is a null set, so intersection of A1 and A3, the probability is 0, right? And the product of individual probabilities is also 0. So this condition also holds. So three out of the 4 conditions hold, but only one condition is not satisfied. So so based upon this, we can conclude that these three sets A1, A2 and A3 are not independent. So this concludes our solution to this problem.